Hello everyone, welcome back to my channel. So in this video we'll see some of the problems on analyticity. Okay, so how to find the given function is analytic or not, and some basic problems, right? Some basic concepts or basic concept problems. Okay, some basic concept problems from previous gate. Okay, so from previous gate questions we'll see. Okay, so we'll see some problems on analyticity and some basic problems from previous gate. Okay, if you are first time to my channel, please consider subscribing. Right, so in the first problem he has given to find whether the following given functions are analytic or not. Okay, so f of z is equal to z bar. So if z is equal to x plus iy, which we have discussed in the previous video, so if z is equal to x plus iy, that z bar will be its complex conjugate. So complex conjugate is x minus iy. Okay, so if x plus iy is the complex number, then its complex conjugate is x minus iy. Only the imaginary part gets complicated. Okay, right, complemented, sorry. Right, so f of z is now x minus iy because z bar is x minus iy. So u is equal to x and v is equal to minus y. So what is ux? That is ux is dou u by dou x. That means you are doing partial differentiation with respect to x. That is, so what is u? X. So dou x by dou x, which is equal to 1. Similarly uy, since there is no y term here, uy is equal to 0 because in u there is no y term. Similarly, what is vx? Vx is 0 because there is no x term in the given function v. Similarly, what is vy? Vy is dou u by dou y, which is equal to minus 1. If you differentiate the minus y with respect to y, so you'll get minus 1. Okay, so ux is equal to vy. This is the condition for Cauchy Riemann condition. So what is ux? Ux value is 1 and vy value is minus 1. So ux is not equal to vy. When ux is not equal to vy, then it is not analytic. Okay, so if the Cauchy Riemann equations are satisfied, then it is called as analytic function. If the Cauchy Riemann equations are not satisfied, then it is not analytic function. Okay, so this is how we can solve. Right, so see the second problem, he has given f of z is equal to mod z whole square. So f of z is equal to, so what is mod z? Mod z is root of x square plus y square. Okay, so modulus of the given complex number, and he has given mod square, so squaring on both sides it will be x square plus y square. So this will be x square plus y square. So this is totally imaginary, real part. So imaginary part you can take it as 0. So u is equal to x square plus y square and v is equal to 0. Okay, right, then what is ux? Ux is dou u by dou x. So differentiating with respect to x, only this, because when you are differentiating with respect to x, y is treated as constant and differentiation of a constant is 0. So dou u by dou x is 2x. Similarly uy, when you are differentiating with respect to y, you are taking this x as constant, so this becomes 0, so you'll get 2y. And since v is equal to 0, so you'll get vx is equal to vy is equal to 0. And here in this case also ux is not equal to vy because ux is 2x and vy is 0. Okay, so it is not analytic. It is not analytic. Okay, right, see the third problem, he has given f of z is equal to z square. So mod z square is different and z square is different. So z is equal to x plus iy, so z square is equal to x plus iy whole square. So this is of the form a plus b whole square. This is a and this is b if you assume. So this is of the form a plus b whole square. So it will be x square plus iy whole square plus 2xiy 2ab. Okay, so this will be x square minus y square, because I square is equal to minus 1. So I square is equal to minus 1. So I square y square. So it will be minus y square plus I into 2xy. Okay, so this is f of z. F of z is equal to x square minus y square plus I into 2xy. Right, so this is your u function, this is your v function. In Cauchy Riemann standard equations, this is u and this is v. Right, so what is ux? Ux is dou u by dou x, that is differentiating u with respect to x, you will get 2x. Okay, so only this term. So this y is a constant, so this becomes 0. Similarly, when you differentiate with respect to y, x becomes constant, so it will be minus 2y. Then what is v? V is equal to 2xy. V is equal to 2xy. So vx is dou v by dou x. When you are differentiating with respect to x, 2 is a constant and y is also constant. So 2y I am writing outside. So differentiation is with respect to x. So dou x by dou x is equal to 1. So it will be 2y. Similarly, vy is equal to dou v by dou y. So when you do with respect to y, x is a constant, so it will become 2x. Okay, so ux is 2x and this is also equal to vy. So vy is also 2x and ux is also 2x. And similarly, uy is equal to minus vx. Uy is minus 2y and minus vx is minus 2y only. So both Cauchy Riemann equations are satisfied. So both the conditions, both Cauchy Riemann equations are satisfied. So that is why this function is analytic function. This function is said to be analytic function. Okay, so this is how, based on the problem, you have to take the real and imaginary parts of a given function f of z and consider that real part as u and imaginary part as v. Then differentiate u with respect to x and with respect to y. Similarly, differentiate v with respect to x and with respect to y. And then you have to check for Cauchy Riemann equations. If both the equations are satisfied, even if one of the equation is not satisfied, then also the function is not analytic. So in this case, in the third example, both the equations are satisfied, so it is an analytic function. Okay, in some cases only one of the condition will be satisfied, that is one of the equations, one of the Cauchy Riemann equations will be satisfied, but the other will not be satisfied, then also it is not analytic. Both conditions must be satisfied. Okay, so next we'll see one more question on analyticity. Okay, so he has given the following function f of z and asked you to find whether the given function is analytic or not. Okay, so the real part we are considering it as u and the imaginary part as v. So I'll rewrite that f of z is equal to x plus e power x into cos y plus, if you take I common, so it will be y plus e power x into sin y. Okay, so this total function is u and this image part is v. So u is equal to x plus e power x into cos y. So first we have to find ux and uy. Ux is dou u by dou x. Always remember, when you are partially differentiating with respect to x, treat all the terms which contains y as constant. So when you are doing with respect to x, treat y as constant. So this is taken as constant. So dou by dou x of x is 1 plus dou by dou x of e power x is also e power x, and cos y is a constant, so we'll write as it is. Okay, cos y. Right, so this is ux. Similarly uy, dou u by dou y. When you are doing with respect to y, treat x as constant. So this term contains only constant term, only constants term, so the differentiation is 0. Plus e power x is a term which contains x, so it is taken as constant like this. And sin y differentiation is cos y differentiation sign is minus sin y, so it will be minus e power x into sin y. Okay, similarly v is equal to y plus e power x into sin y. So vx, that is dou u by dou x with respect to, when you are differentiating with respect to x, dou v by dou x, right? So when you are differentiating with respect to x, y is constant, so differentiation of a constant is 0, so you'll get e power x, dou by dou x of e power x is also e power x into all the terms which contains y are taken as constant, so you'll get the same term here. Okay, so vy is dou v by dou y, dou v by dou y. So with respect to y you are doing, so it will be 1 because dou by dou y of y is going to be 1. So all the terms which contains x is constant, so it will be constant e power x into d by dx of sin y is cos y. Okay, differentiation of sin y is cos y, right? So you have found ux, uy, vx and vy. So Cauchy Riemann equations, CR equations are, so ux is equal to vy. So you have to check whether ux, what is ux? 1 plus e power x cos y, and vy is 1 plus e power x cos y. So this is satisfied, and vx is equal to minus uy. So what is vx? Vx is e power x sin y, and uy is minus e power x sin y. So vx is equal to minus uy. This is also satisfied. Okay, so both the Cauchy Riemann equations are satisfied, therefore the function is analytic function. Okay, so this is how we can solve for any given function. We can check the Cauchy Riemann equations by taking the imaginary and real parts. Okay, so imaginary part we'll consider as v, and real part we'll consider the function as u. So both u and v are functions of x comma y again. So both v and u are functions of x comma y. That is what we have taken. F of z is equal to u of x comma y plus I into v of x comma y. Okay, and we will check whether Cauchy Riemann equations are satisfied by considering ux, uy, vx and vy. Okay, so this is how we can solve. So next we'll see some more two more problems. So these two problems are asked in previous GATE questions. Okay, so in the previous GATE exam papers these two questions have been asked. Okay, so let's solve them. So here's, in this problem he has given log of minus n. So we have to prove that log of minus n is equal to I pi plus log n. Okay, so log of minus n can be written as log of n into minus 1. Okay, so n into minus 1 is minus n again. So this is of the form log of ab, when log of ab will be log a plus log b. So this can be written as log n plus log of minus 1. Okay, so what is we can write minus 1 as, how can we write minus 1? E power I pi. E power I pi. What is e power j theta? So e power I theta is cos theta plus j sin theta, or cos theta plus I sin theta. So e power I pi is cos pi plus I sin pi. So cos pi is minus 1 and sin pi is 0, so this total becomes 0, so you get only minus 1. So in the place of minus 1 you can substitute with e power I pi. So this now becomes log n plus log of e power I pi. Okay, e power I pi, that's all. So log of a power m can be written as m log a. So this is a and this is m, so it is of the form log a power m, so we can write it as m log a. So log n plus I pi into log e. So we know that log e value is equal to 1. Okay, so log e value is 1, so it will be log n plus I pi. Log n plus I pi. So that is what we have to prove. Okay, so in the gate question, so this will be given as one of the option. Okay, very important question, you have to remember the procedure, right? So the next question, this question is very important question, asked in each and every branch. Okay, in different years he will be asked, he has asked in different branches. Okay, so almost all the branches have this question, this type of question. Find the value of I power I. Okay, so W is equal to I power I. So taking log on both sides, taking log on both sides. Okay, so considering logarithm, so it will be log of W is equal to log of I power I. Okay, so using this formula, log a power m is equal to m log a, so log W is equal to I into log I. Okay, so we can write I as e power I pi by 2, e power I pi by 2, because what is e power I pi by 2? So it will be cos pi by 2 plus I sin pi by 2. So we know that cos pi by 2 is 0 plus I into 1, so it will become I. So in the place of I, you can substitute with e power I pi by 2. So I am substituting here I into log of e power I pi by 2. This is log W. So log W is equal to I into, so same log of a power m, log of a power m form, so it will can be written as m log a. M is I pi by 2 into log e. Log e value we know that it is 1, so this becomes log omega is equal to I into I square. So we know that I square value is equal to minus 1, so I square into pi by 2, so minus 1 into pi by 2, so this becomes minus pi by 2. Anyhow this value is equal to 1. So when log W is equal to pi by 2, so what is W value? E power minus pi by 2. That's all. Okay, so e power minus pi by 2. Right? So this logarithm is natural logarithm. Okay, so e power minus pi by 2 is the answer. So I power I is equal to e power minus pi by 2. Okay, so this is very important problem if you are preparing for GATE exam. Okay.